lesson is a lesson that will review basic algebra. Hopefully, algebra you learned in elementary school. Now, I'm also going to use these things called algebra tiles to help you visualize algebraic equations. And I don't know if you remember doing this in elementary school, but if you did not, that's okay. You get to learn it with me. And if you did, this is a review. We model algebra tiles this way. We use these rods to represent the variable, and for positive variables we usually use a solid rod. So just draw in a solid rod, shade it in, and then the numbers, a positive number, would be represented by one of these tiny little squares. Sometimes they're drawn in red, but once again they're shaded in solid. A negative variable then would be represented by, once again, a rod, but we'll use not a shaded one, but I guess a open or unshaded one. And same thing with the -1 value. It'd just be one little small unshaded square. Okay. If you want me to use the right colors, I guess I can make that red. So let's try these examples here. Example number 1 says solve each equation using algebra tiles. And I've actually drawn out the algebra tiles for you for example A. So x plus 2, here's my x, that's the rod, and then plus 2, so there's 2 positive squares, and this equals 2, so on the other side I have 5 red squares. So x plus 2 equals to 5, and you're trying to solve for x. So I want you to find out what x is equal to, meaning I want you to find out what one of these rods represents. Well, this is an equation. I hope you learned that when you have an equation, they have to be balanced. So whatever you do to one side of the equation, you've got to do to the other side. So if I wanted to solve for x, I want x by itself, which means I'll need to take away these 2 positive red squares. And once again, if I do that to the left side, I have to do the same thing to the right side. So when I take them away, what do I have left over? And let me draw this underneath. We'll have one solid rod left over on the left, which represents x. And by taking away 2, we'll have 3 squares, solid of course, left over here. And what does this represent? This says x is equal to 3. And that should make total sense. What plus 2 gives you 5? Well, it's 3. 3 plus 2 gives you 5. Okay. Let's try part B now. We have n plus 3 equals to -2. So let's once again draw these out using algebra tiles. So n is my variable. It's a positive variable. So let's draw in a positive rod. Plus 3 means we need 3 small little squares that are solid. So there's my left side, n plus 3. And this equals to -2. So on the right hand side, I'll draw 2 small squares, but these are negative, so they are unshaded. Now, how do we do this and how can we solve for n? We're trying to now solve for n by itself, so we're going to have to get rid of 3 of these solid red dots. And what we do to the left side, we've got to do the right side. But wait, there's nothing to get rid of. There's no positive red squares. What do we do? Well, just like how we did the integers, we're going to put in some 0 pairs. So here's 1 0 pair, a positive and a negative together. I need 3 of them, so I'm going to make 3 0 pairs. And once I put them all in, now I'll have enough positives to also take those away. Goodbye, goodbye. And now we're left with the following. On the left side, we have 1 solid rod, which represents our positive n. And on the right-hand side, we've got 1, 2, 3, 4, 5. And what does this represent? N equals to -5. And if you want to double check, plug it back in to our original equation. So -5 plus 3, yeah, that's -2. Okay. It's the same thing for C and D, so let's try these now. So C is k minus 2 equals to 1. I've got my long rod that represents my positive variable, or k. Minus 2 is the 2 open squares, or white squares, and that equals to 1. So once again, I want to remove 2 white squares. I don't have any. So guess what I'm going to have to do? I'm going to have to now add in, once again, 0 pairs. So once again, a 0 pair is just a pair of positive and negative together. I need to put in 2 pairs in this case because I want to eliminate 2 white ones. And now, what do we have left over? I've got, once again, my k, and then I have now 3, which makes hopefully total sense because k definitely equals to 3. 3 minus 2, yeah, that equals to 1. Okay? Let you try D. I want you to try D. You can do it on your own, and if you do, I suggest you pause the tape right now. If you need some help, continue the video and watch and listen to me do this one for you. Here we go. M. So that's M, a solid rod. How do we show -1? Yes, that is a open square. And this equals to -5. So 1, 2, 3, 4, 5. There are 5 of these open squares or unshaded squares. Our goal is to solve for m, or the variable, so we want the one rod by itself. Goodbye to this one. Goodbye to this one as well. Once again, the goal is to take away things. If you take away 1 from the left, you got to take away 1 from the right. And what's remaining? We've got our 1 positive rod. And now we have 4, 1, 2, 3, 4 open squares. So therefore, our answer for m is equal to -4. Okay? Now, you might be thinking, Mr. Lee, do we always have to draw pictures? No, but I'm asking you to draw pictures because I hope this helps you with the next part. The next part is called, maybe, I guess there's a few ways of saying it. Some people call it algebra. Some people call it using the opposite operation. So I'm going to ask you in example number 2 to do these questions. Now they're exactly the same as the ones from above. Okay. Now what do you notice for 2a? X plus 2 equals to 5. Well, that's the same as this one up here, right? X plus 2 equals 5. How did we solve this one? We removed 2 from both sides. So ultimately, we call this opposite operation because you see the plus 2 here? Well, we're trying to remove the positive 2, and we do that by subtracting 2 on both sides. And that leaves us with just x on the left because 2 minus 2 is 0. And on the right-hand side, 5 minus 2 gives us 3. And there's our answer. X equals to 3. Same as above? Yep, totally the same. That's good. So why don't you try B then? We got n plus 3 equals -2. What's the opposite operation of plus 3? You've guessed it if you said -3. So let's subtract 3 on both sides. So what do we have now? N equals to, and -2 minus 3, that's -5, which is also the same answer as above. Yay! Let's do the same thing with C and D. So now we have k minus 2 equals to 1. If we use this idea of opposite operation, what's the opposite of minusing 2? I heard someone say plus 2. Yippee! That is definitely correct. So then you're left with k on the left side because -2 plus 2 is 0. And then 1 plus 2 is 3. Ta-da! And that's the answer from above. Yay, yay, yay. It makes sense. And finally, let's do the same thing with D. M minus 1 equals to -5. So let's go ahead and do opposite operation. The opposite operation of -1 is +1, or sorry, -1, I should say. So we must do the same thing to both sides. So now we have m equals to -5 plus 1. That's just -4. Ta-da! Yay! So I hope that you won't always be drawing pictures, but I do want you to understand where the pictures come from. In our subsequent studies on algebra, I will be asking you to draw pictures, so you need to learn how to do that. And so that's why I show that to you here as well. Okay? Now, turn to the next page, and you'll see a whole bunch of practice questions. So I'd like you to try these. Okay. And you can draw pictures or you can do opposite operation, either or. But I would like you to get comfortable with the opposite operation method because that is, of course, much quicker and a little bit easier on the pen, right? You don't waste as much ink. So I don't care how you're going to do this, but you do it. Okay, so stop the tape right now and work on these questions. And when you're done, come back and you'll see the answers. Okay, press pause. Now, okay, now H might be a little bit different because you have the order messed up. But once again, the goal is to isolate X. So this is like a positive 2. So we're going to have to subtract the positive 2. And you get X equals to negative 5. I guess when you do these, be careful with integers. And this is why you needed to learn the integer section very well. Chapter 8, I believe, of Math 8. Once again here, reversed order, but nonetheless, what's the opposite of negative 5? It's plus 5. What's 0 plus 1? 1. There you have it. All done.